So if I was to start filling this out, let's start with the first one. What's 2 squared? 4, right? So we have 4. And then now we have 2 cubed, which just basically says what? Yeah. For 2 squared, we multiplied 2 times 2 and got 4. For 2 cubed, all you do is just say, okay, that means 1 more times 2, isn't it? So I'll just take what I had previously, and I'll multiply it times 2. And so that means 4 times 2 is 8. 2 to the 4th ends up being what? 16. Times 2 again. And then times 2 for the last time. Because honestly, I don't want to have to sit there and go, okay, 2 times 2 times 2 times 2 times 2, 6 times. What's a pattern that I can use to make my job a little bit easier? And that pattern is going to be just take what's above and multiply it times 2, right? 3 squared, what's that? 9. Now we do 3 cubed. Let's do the same thing we did before. So what's 9 times 3? 27. 27 times 3. Good. 81. 81 times 3. 243. Guys, also, to make your job a little bit easier, if you want, this 3 to the 4th could break up into 3 squared times 3 squared. What's 3 squared? 9. What's 9 times 9? And that matches there. Do you see that? It's another way of doing it. You can break them up, guys, if you want, into smaller groups. 4 squared. 4 times 4? 16. 16 times 4? 64. 64 times 4? 256. Good. 256 times 4 again? 1024. Good. All right. 5 times 5? Times 5 again? Good. And then 5 times for the last time. There you go. All right, so going into the exponents, now let's talk about how we can write an exponent form. So we have a few options here we can rewrite on this. So 1 over 8 we want to write as an exponent. We don't want to write 1/8, we want to write it as an exponent. As a matter of fact, we want to write it down to the reduced form of the exponent, which means what is the smallest base. Because if we talk about exponents, guys, there's 2 parts in exponent. There's the base, which is a number that's being multiplied over and over again. In this case, for our examples we did earlier, like for the very first one, 2 squared, I should do a different number. 2 cubed, the base is 2, and the exponent is 3. So when we do 1/8, we want to do the lowest basis possible. But let's take it one step at a time, okay? So if anything is 1 over, does anybody know what exponent that needs to be? Yes. So 8 to the negative 1. Good. And can we rewrite 8? Is that one of the numbers that we found up here when we were doing writing out our exponents? 2 to the what? 2 to the 3rd. 2 cubed, right? So we could actually go in and rewrite this as 2 to the negative 3. So not only do we change to a negative, but we also go ahead and include the 2 to the 3rd as well. So let's go and do that information. Let's take that and see what we can rewrite as 1 over 25. Well, let's take it a different angle. How can I rewrite 25 as an exponent? 5 squared. And now I need to get rid of the 1 over. It's negative. And now for this one, they want us to go ahead and simplify. And so we go ahead and do this the best way we can in reducing it, okay? So what you notice is we have 3 to the 3rd raised to this power. you remember back in law of exponents, what is it when something's raised, when a power is raised to a power? What do you do with those two numbers? What do you do with the 2 and the 3? Multiply them. Multiply them. Because if I was to write this out by hands, what do I do with all those 2's now? Be careful. You multiply them when they're raised to a power. When you multiply two numbers that have the like bases, you're adding the exponents. When you divide, you're subtracting the exponents, okay? So this one we're going to add, right? So 2 plus 2 plus 2 is what? What's 3 times 2? So it's just another way of showing you guys. It's expanding that cubed, just writing it out 3 times, and then doing it that way as well. So for this one here, we're going to do the same thing. We're going to multiply 3 times 2x minus 1, okay? So I would rewrite it like this. Like that. And now we distribute, right? If you have a parentheses with a number in front. There you go.
We're not even going to worry about leaving it alone.
Yeah, that's it. Yeah, I know. From there, you can't really do anything else. Because from here, Sean, we can't raise 3 up to a 6x minus 3 power because we don't know what x is. If they give us x value, Sean, then we can go ahead and do that, right?
Yeah.
But for now, there's nothing. We have to stop right here. All right, so let's look at the next one. So we've talked about inverse, which means it's just a negative. Now let's talk about a cube root or a square root. Okay? Now, with that being said, this actually ends up being and looking like a fraction. Like this. Do you see where the 3 comes from? Where does the 3 come from? Exactly. It's the 3 in the front. That's where the 3 comes from, and that's why it's 1/3. So let me jump over. I'm going to come back and finish this later, guys, but let me jump over real quick and come over to here. What do you think the square root of 5 could be rewritten as? 5 to the 1/2 power. Good, Tyson. That's right. Square root, square. So you could rewrite it as 5 to the 1/2 power. Cube root to the 1/3 power. Fourth root to the 1/4 power. Do you see what's going on? Whatever root I'm doing it to, that's the 1 over. It's the fraction, okay? So let's go back to this problem here. Can I rewrite 125 as maybe a exponent? Do we have 125 up in our work we did earlier? What is it? 5 cubed, right? Do y'all see that? So I could rewrite what's in the parentheses to 5 cubed to the 1/3, correct? Do y'all see what we're doing here, guys? Just taking these terms, these math terms, and just rewriting them in this more of a simplified version. Because look what happens next. What did we just establish in the problem earlier? What do we do with numbers when we raise it to a power? What do we do with exponents when we raise them to a power? You multiply, exactly. So I'm going to now, what do you think I'm going to do with this 3 and 1/3? Well, yeah. But it's multiplied, right? But when you're multiplying by 1/3, what are you actually doing? Dividing by 3. So what's 3? What's 3 times 1/3? Or what's 1/3 of 3? 1. So actually what happens is, they go out, don't they? They cancel each other. So guess what the third root of 125 is? 5. Any questions about those guys? So So going through the laws, the first one says laws of exponents. It talks about, and stuff you've already seen before in Algebra 1 and Algebra 2, if you're multiplying two exponents with like bases, you just add the exponents together, and that's what's talked about here. And then, of course, if you raise 1 to any power, it's always going to give you 1, right? What's 1 to the 100th power? That's 1 times itself 100 times. So it ends up just being 1. This is what we saw earlier in the warm-up. If you take a power and you raise it to another power, bless you, you end up just multiplying those together. We just talked about this one as well. With the negative power, it ends up being the inverse. This one's kind of important here, guys. You got to realize this, okay? Let me show you something different than what we're talking about. See the a times b raised to the, bless you, is that to the s power? Can y'all see it better in y'all's notes? Is it s power? Yes? Okay. Be careful, guys, because I've seen this done too many times. You see this here, and it's a times b. Okay? It's a times b. I have seen this mistake happen. Guys, that's not true. That's not true at all. Okay? This is false. This does not equal that at all. I've seen people go in and take that exponent outside the parentheses and just distribute it to the terms inside. You got to realize, and this is where vocabulary is really important, you got to realize there is a monomial. What does monomial mean? 1. There is one term inside the parentheses. Yeah, but Coach Espender, it's A and B. That's 2 letters. Yeah, but guess what? They're being multiplied together, which strings them together and makes them one term. It's not A plus B. A plus B, this right here, is a binomial. Binomial has different rules than if it's just a monomial. Okay, y'all follow me on this? All right. That's the reason why it looks like that. And of course, anything raised to 0 power is 1. Yeah, we'll talk about growth factor from there on, okay? All right. So it says the 1-to-1 property, if a to the x equals a to the y, then x equals y, which just says this, guys. If I have an equation where the bases are the same, if I have an equation where the bases are the same on each side of the equal sign, you could simply just rewrite the equation with the exponents, okay? So if you look at the first one, 7 to the x equals 7 to the 4th. Well, 7 and 7 are common. Do y'all agree? Basically what happens, guys, is they go away and you're just left with the equation x equals 4, and you're done. Which should make sense, guys, is what power do I need to raise x to in order for it to equal, what power do I need to raise 7 to in order for it to equal 7 to the 4th power? 4, right? And that's kind of an easy example there for you guys just to see how that works. So look at number 2. Number 2 is going to require a little bit of extra work. And the fact is, can I rewrite 8 as an exponent with a base of 2? Can I rewrite 8 as an exponent with a base of 2? And this is why we had you guys do this on the warm-up. Okay? On the warm-up, what did we realize 8 can be rewritten as? 2 to the 3rd. Good. Right? Now we have achieved where both our bases are the same in the equation, and using the 1-to-1 rule that we just discussed, we can cancel those out, and you're left with that. And granted, guys, there's probably another way to do this. You'd be like, okay, what do I need to multiply? How many times do I need to multiply 2 times itself to get 8? 2 times 2 is 4, times 2 is 8. Oh, answer's 3. Totally can do that. But guys, these examples are pretty simple right now. It gets a lot more elaborate. And of course, you're going to do equations. Okay, so right now, early on, these will kind of go out pretty easily, but then it'll do that. I do have good news for you guys. If I want to go ahead and bring any enlightenment into your Tuesday after a 4-day weekend, there will be a section on here that you'll have to use a calculator on. So you'll be getting your calculators back for 1 day. And on the test, it'll be allowed on the test as well. So just a heads up there, okay? So hopefully that enlightens your day. All right, so let's look at number 3. Number 3, we have a few options, but let's just go ahead and do something that's probably the straightforward one. Can I rewrite 16 as an exponent where the base is 4? 4, 2. And so you ask yourself, can I raise 4 to a power and get 16? How many times do I have to multiply 4 times itself to get 16? 2. So I'm going to rewrite this problem here. 4 raised to the 2. And be careful. Make sure after you rewrite 16 squared, or 16 is 4 squared, make sure you use parentheses. Because you've got to note that it's being squared. Have we achieved where both the bases are the same? So now I have this simple equation of this, and now we solve, right? Distribute the 2. In solving, what's the next step? Good. And we're done. So 4 raised to 3 times what value will equal 16 raised to some value minus 3. And that magic number is negative 6. Number 4. What do you think is going on with number 4, guys? Can I rewrite 81 as 3 raised to a power? Yes. How many times? You even went further. Peyton went a little bit step further. I'm going to take a step back, Peyton, from what you said. I'm going to do this first. Okay? Peyton already said negative 4, which he already sees that inverse thing going on there. So he knows this exponent's going to have to be negative, but I'm going to go and do it one step at a time. And he's right. The next step would have to make this 4. That doesn't match yet. It's 1 over 3 to the 4th power. It's not just 3 raised to some power. So now I need to take another step. And now we have 2 exponents equal to each other that have like bases. That's exactly what we need. Because then it cancels. Whoops. And you're left with x minus 1 equals negative 4. Bless you. What do we do now in order to get this to solve? Number 5. Well, the good news is I see 25 in both of them. Do you see 25 on both sides? That's nice. There's no reason having to look at a table or thinking about multiplying anything times itself. However, it's not 25 as a base just yet. Which one do I need to change? Left or right? The right. What do I need to do to it? How do I get the 1 away from the top of 25? It's inverse, that's right. It's actually 25 to the negative 1, right? 1 over 25 is 25 to the negative 1 power. So I just rewrite it in parentheses. I'm not going to do anything just yet on this first step. This first step should just be a simple rewrite here. Just like what we did with number 4, we just take it one little step at a time, guys. So you go in, here we go. We're getting close. We're getting close to having both sides being equal bases. However, the right side has a set of parentheses and we need to get rid of it. So look at the scenario we have here. We have an exponent that's raised to an exponent. And what's the rule we do for that, guys? Good, you multiply. And so we'll multiply that negative 1 times 4 and that negative 1 times negative 2x. Do an equation where both bases are equal? Yep. And now we have just a simple one variable equation to solve, right? Subtract 2 minus 8. (8x equals negative 12). What's last? So x equals what? 3 halves? 1 and 1 half. Got 3 halves. Always fraction form, please. Always fraction form answers. I mean, granted, you will have a calculator for this test, but just leave them all in fraction form, please. All right, guys, I'm going to let you do the last two. Go ahead, work through it for a few minutes, and then we'll get back and see how we do, okay? Just write out what you did, okay? Say anything. So like I was saying, guys, with number 10, we got to have the like bases, and we already established that. We figure out 4 needs to be squared. That one does not need to be touched. And then 16, we said, is to the 4th power. So we end up with 2 to the 2x times 2 to the x squared to the 2x times 2x squared equals 2 to the 8. Well, as we talked about already, all these 2's go away, and you're left with 2x plus, because the bases are being multiplied, equals 8. We have to solve this equation, guys. So this is something we just talked about, right? How do we solve, bless you, how do you solve a quadratic? What has to be true about the equation? Has to equal 0. Has to equal 0. So I'm going to move the 8 over. Set it equal to 0. What are factors of negative 8? If I combine them together, it gives me positive 2. Positive 4 and negative 2. And we'll stop right there for that problem. There's more to do, but I'm going to stop right there. Technically, you need to plug the negative 4 and 2 into the equation and see if it's true. Sometimes, there's ambiguous cases sometimes, but we're not doing that, okay?
So will it always turn into an answer like that, or will there be ever like?
No. This was just because the second term, Sean, on number 10 is x squared. Do you see the x squared? It tells you there's 2 answers. If you see x raised to a power, that tells you how many answers there's going to be. Since x squared is present, that means it's 2 answers. All right, let's finish off with number 11. If 5 to the negative x power equals 3, what does 5 to the 3x power equal? How do you think we do that? Kayla, anything? She says no. Well, what do we do? What do we do to make that happen? What do you do to go from, I shouldn't put equals, sorry. What stuff did we do to make it go from negative x to positive 3x? What did I do to this equation right here to turn it into positive 3x? So let me simplify. What do I do with this in order for it to equal 3x? You can't add. Yes, sir. There you go. What we did, guys, is we took 5 to negative x and we raised it to the negative 3 power. If you take 5 to the negative x and raise it to the negative 3 power, you will get 5 to the 3x power. Do y'all follow me on that? So that means I need to take the 3 and raise it to the negative 3 power. Okay? So the first thing we know, it's negative. So that means it's going to be 1/3 cubed. What's 3 to the 3rd, guys? 27. Okay? Alright, here's what I want you to do now, guys. You're going to partner up. Get a book. Page 284. We're going to do 61 through 84.